Hello, good morning to each and everyone. So, welcome to our in the class. And this session, we are going to talk about measures of variability or measures of dispersion. So, ang mga measures of variability tulad ng range, variance, and ito ay maaring gamitin sa maraming sitwasyon pangsukatin yung pagkakaiba o yung variabilidad ng bawat data. So ito ay magagamit natin sa ating, say for example, sa ating paaralan. Maaaring gamitin natin ang measures of variability upang suriin ang mga score na mag-aaral sa isang pagsusulit. Kung mataas ang standard deviation ng mga score, maaaring magpapahiwatig ito na may malalim na pagkakaiba sa performance ng mag-aaral. Ito rin ay maaaring maging batayan para sa mga karagdagang pagsasanay o suporta ng ating mga estudyante na nangailangan. Maring ito rin ay magagamit sa medical field. Maring gamitin ang measures of variability para sa pagsusuri ng mga clinical na data tulad ng blood pressure, sugar level, o cholesterol level. Ito ay makakatulong sa pagtukoy na may mataas na panganib ang kondisyon ng isang pasyente tulad ng hypertension o diabetes. Kung maring gamitin din natin ang measures of variability sa larangan ng finance, na kung saan ito ay mahalaga sa pagsusuri ng stock prices, investment returns, at iba pang financial data. Kapag mataas kasi ang standard deviation ng isang stock, ito ay maaaring nagpapahiwatig na may malaking risk sa pag-invest nito. So, ang measures of variability ay maaari pa itong magagamit sa ibang larangan tulad ng psikolohiya, sa engineering, sa research, at iba pa. So, by definition, when we talk about variability, it describes how far apart data points lie from each other and from the center of distribution. Along with measures of central tendency, the measure of variability will give us descriptive statistics that summarizes a given data. It is also referred to as spread, scatter, or dispersion. So, range refers to the difference between the highest and the lowest values. When we talk about interquartile range, it refers to the range of the middle half of the distribution. While the standard deviation refers to the average distance from the mean, and variance refers to the average of square distance from the mean. So these are the four important measures of variability or measures of dispersion, which are very essential in several disciplines. As what I have mentioned a while ago, we can definitely make use of these measures sa larangan ng meteorolohiya. Tulad ng sa pag-aaral ng klima o sa panahon, ang measures of variability ay magagamit upang suriin ang pagbabago ng temperatura, humidity, o rainfall. So ito rin ay makakatulong sa pag-unawa sa climate patterns at pagtukoy sa mga lugar na madalas tamaan ng malalakas na bagyo o pag-ulan. Magagamit din natin ang measures of variability sa larangan ng market research. Kung tayo po ay nagkukondak ng mga survey or market research studies, maaaring gamitin ang measures of variability upang malaman ang pagkakaiba-iba sa mga sagot ng mga respondents. Ito ay magbibigay impormasyon ukol sa mga preference ng mga clients, ng mga tao, at maaaring magagamit sa pagbuo ng marketing strategies. Pwede rin ito magagamit sa manufacturing, sa industriya ng manufacturing. Ang measures of variability ay maaaring gamitin upang suriin ang kalidad ng mga produkto Kapag mataas ang standard deviation sa mga dimension ng produkto, ito ay maaaring nangungahulugan na may problema sa production process. So, ang measures of variability ay mahalaga no, sa pagsusuri ng data sa iba't ibang larangan upang maunawaan natin ang pagkakaiba at pagkakapare-pareho sa mga obserbasyon. Ito ay nagbibigay ng insights no, sa paggawa ng mga decisions natin, no, sa pagtukoy ng mga problema at sa pagpaplano para sa mga hakbang na kinakailangan. So why does variability matter? While the central tendency or average tells us where most of the points lie, variability will somehow summarizes how far apart they are. This is important because the amount of variability determines how well you can generalize results from the sample to your population. Low variability is ideal because it means that you can better predict information about the population based on sample data, while high variability means that the values are less consistent, so it is harder to make predictions. Data sets can have the same central tendency, but different levels of variability, or vice versa. If we know only the central tendency or the variability, we cannot say anything about the other aspect. Both of them together, we can give a complete picture of the data. So say for example, a variability in normal distributions. So we are investigating the amount of time spent on phones daily by different groups of people. So using random samples or simple random samples, you collect data from three groups. Sample A, it is composed mainly of high school students. Sample B, which is composed of college students. And sample C, which are composed of adult full-time employees. So in the figure, it shows the average phone use per day in minutes of sample A in blue, sample B in green, and sample C in yellow. If you have observed, all three of our samples have the same average phone use at 195 minutes or 3 hours and 15 minutes. This is the x-axis value where the peak of the curves are. Although the data follows a normal distribution, each sample has different spread. If you have noticed, sample A has the largest variability, while sample C or the adult full-time employees has the smallest variability. That just simply means that a small measure of variability, which is the sample C, indicate that the data are clustered closely around the mean, while the big measure of variability indicates that the data are far away from the mean, which is 3 hours and 15 minutes. So that just simply means also that a small measure of variability is more homogeneous, less variable, more consistent, and more uniformly distributed. While sample A are heterogeneous, more variable, less consistent, and less uniformly distributed. So those are the things that we have noticed on this figure. Moving on, one of the four measures of variability is actually range. No? It tells us the spread of our data from the lowest to the highest value in the distribution. It is the easiest measure of variability to calculate. So to find the range, we just have to simply subtract the lowest value from the highest value in the given data set. So say for example, in this particular given data set, 72, 110, 134, 90, 238, 287, 305, and 324. The highest value is actually 324. And the lowest value is 72. Therefore, in finding range, that is actually 324 minus 72 is equals to 252. So that means that the range of our data here is 252 minutes. Because only two numbers are used, the highest value and the lowest value, the range is most likely influenced by outliers. And it does not give us any information about the distribution of values. So it is best no, to use in combination with other measures. Another measures of variability is the interquartile range. This will give us the spread of the middle of our distribution. So for any distribution that is ordered from low to high, the interquartile range contains half of the values. So this is where our IQR is. So 50%, while the first quartile or the Q1 contains the first 25% of the values. And the fourth quartile or Q4 contains the last 25% of the values. So again, this figure is our interquartile range on a normal distribution. Again, the interquartile range is the third quartile minus the first quartile. So this would be our formula in finding the IQR. So IQR or interquartile range is the third quartile minus the first quartile. This will give us the range of the middle half of the data set. So for example, to find the interquartile range of the 8 data points, 72, 110, 134, 190, 238, 287, 305, and 324, we first find the values of Q1 and Q3. Because as what I have said, in finding the IQR, we have to subtract Q3 from Q1. So in finding the values of Q1 and Q3, we have to multiply the number of values in the data set. So since we have eight, no? Eight values in the data set, so that is actually in finding Q1. So to find the values of Q1 and Q3, we have to multiply the number of values in the data set, which is 8, by 0.25 for the 25th percentile or Q1. And we have to multiply our data set, which is 8, by 0.75 for the 75th percentile or Q3. So that is actually, using our calculator, that is actually 6, no? That means Q1 is the value in the second position, which is actually 110. And Q3 is the value in the sixth position, which is 287. So, since interquartile range is the difference between Q3 and Q1, so substituting the value, Q3 is in the sixth position, which is 287, minus Q1, which is in the second position, which is 110. So our interquartile range is 177. Again, the interquartile range of our data is 177 minutes. Just like the range, the interquartile range uses two values in its calculation. But the interquartile range is less affected by outliers. The two values come from the middle half of the dataset. So they are unlikely to become extreme scores. The IQR also gives a consistent measure of variability for skewed as well as for normal distributions. So moving forward, every distribution can be organized using a 5-number summary. So we have the lowest value, the 25th percentile, or Q1, the median, which is equivalent also to Q2, and of course, the Q3, which is the 75th percentile, and the highest value, or the Q4. These 5-number summaries can be easily visualized using box and whisker plots. In this figure, for each of our samples, the horizontal lines in a box show Q1, the median, and of course, Q3, while the whiskers at the end show the highest value and the lowest value. So this is the box and whisker plots for sample A, for sample B, and for sample C. Moving on, another measures of variability that we're going to discuss is all about standard deviation. This is the average amount of variability in a given data set. It will actually tells us on average, how far its scores lie from the mean. The larger the standard deviation is, the more variable the dataset is. Again, the larger the standard deviation is, the more variable, the more heterogeneous, the more inconsistent, or the less uniformly distributed the dataset is. So again, ang standard deviation ay isang statistical measure na ginagamit natin upang sukatin ang pagkakalat o pagkalayo, no? O yung tinatawag nating variability ng isang dataset. Kapag ang score ng isang bata ang ginagamit bilang basihan, no? Bilang basihan, ang standard deviation ay nagbibigay ng impormasyon ukol sa kung gaano kalayo o kaigting ang mga score ng iba pang mga bata mula sa average o mean score ng batang yon. Kaya kapag ang standard deviation ay mababa, nangangahulugan ito na ang mga score ng mga bata ay malapit sa average score. At ang variabilidad ay mababa. On the other hand, kapag mataas naman ang standard deviation, nangangahulugan ito na ang score ng mga bata ay malayo sa average score at ang variabilidad ay mataas. Ito ay maaring magkakaroon ng implikasyon, no, sa pag-aaral o sa pagsusuri ng performance o kakayahan ng mga bata. Mas mataas na standard deviation ay maaring nagpapahiwatig na mas malakas, na mas malawak ang range ng mga score. Samantalang mas mababa, ito ay maaring nagpapahiwatig na mas consistent ang performance ng mga bata. Sa industriya ng aviation, ang standard deviation ay maaring gamitin sa iba't ibang paraan upang ma-analyze ang data, matukoy ang pagkakaiba-iba, at mapabuti ang kaligtasan ng mga pasahero at operasyon. Paring ito ay gamitin sa maintenance and reliability analysis na kung saan ang standard deviation ay maaaring gamitin upang suriin ang data tungkol sa pagkakabasag o pagkakaroon ng problema sa aircraft. Yung mga parts nito o different components. Kung mataas ang standard deviation para sa isang particular na component, ito ay maaaring nagpapahiwatig may malalang issue sa kaligtasan o reliability nito. Maaaring gamitin ang data na ito upang mas mapabuti ang mga programa upang magkaroon ng regular na pagmamanman o maintenance. Kalimitan din, ginagamit ito sa mga flight data analysis. Sa pag-aaral ng flight data recorders or black boxes, maaaring gamitin ang standard deviation para suriin ang mga variances sa performance ng mga flight parameters tulad ng airspeed, altitude, at iba pa. Ito ay nagbibigay ng impormasyon ukol sa kung gaano kalawak ang pagkaiba-iba ng mga parameters na ito sa flight operation. Maaaring gamitin din sa safety and risk assessment. Halimbawa sa pagsusuri ng aviation safety data, ang standard deviation ay maaaring gamitin upang tukuyin ang mga patterns ng mga insidente o aksidente. Kung may mataas na standard deviation sa isang particular na uri ng insidente o sa isang lokasyon, maaaring magkakaroon ng pangangailangan para sa karagdagang safety measures o regulasyon. Pwede rin naman sa operational performance analysis. Tulad sa mga airlines, no, maaaring gamitin ang standard deviation upang suriin ang performance ng mga aircraft yung routes nito, yung flight schedule, at iba pang operasyon. Kung mataas ang standard deviation sa oras ng pag-alis o pagdating sa mga destinasyon, ito ay maaring magpahiwatig ng kakulangan sa operational efficiency at maaring magdulot ng delay sa mga flight. So lahat ng mga ito ay ginagamitan ng standard deviation. Ito ay nagbibigay daan, no, sa atin upang masuri ang data at pagtuunan ng pansin ang mga aspeto sa operasyon na nangangailangan ng mga hakbang para sa kaligtasan, efficiency, at kakayahang umaksyon sa mga pagkakabasag o anumang issue sa aviation industry. So going back to our topic, which is standard deviation, again, it tells us how, on average, how far its score lies from the mean. The larger the standard deviation is, the more variable the data set is. We have 6 steps in finding the standard deviation. First thing that we are going to do is to list its score and find the mean. Second, subtract the mean from each score to get the deviation from the mean. Third, square each of this deviation. Fourth, add up all the square deviation. Fifth, divide the sum of the square deviation by n minus 1 for a sample and n for a population. And of course, find the square root of the number we found. So, for example, we have here a given data set. So for example, we have data. This would be our samples. So what we are going to do first is step 1, we have to list each score and find their mean. So we have here sample. We have 72, 110, 134, 190, 238, 287, 305, 324. So this would be our X, the data samples. So from this given data, we have to find the mean. And in finding the mean, we are going to add all this data divided by 1, 2, 3, 4, 5, 6, 7, 8. So using your calculator, we have 72 plus 110 plus 134 plus 190 plus 238 plus 287 plus 305 plus 324. Then we have a sum of 1,660 divided by 8. Then we have a mean of, or this, a mean of 207.50. Step 2 is to look for the deviation from the mean. Deviation from the mean. And in finding the deviation from the mean, we have x minus the mean. So we have actually 72 minus 207.50, that will give us negative 135, no? 0.50, then 110 minus 207.50, that will give us negative 97.50. Then 134 minus 207.50, that will give us negative 73.50. Then 190 minus 207.50, that will give us 17, negative 17.5. 238 minus 207.50, that will give us 30.50. Then 287 minus 207.50, that will give us 79.50. And then 305 minus 207.50, that will give us 97.50. Then the last one is 324 minus 207.50, that will give us 116.50. So our next step is to find the difference between, our next step is to find the square of the difference between the data points and the mean. So that is actually step 3, no? And 4. We are actually finding the squared deviation. So using our calculator, so we have, so negative 135.50 squared, that is actually 18,360.25. No? So we have 18,360.25, negative 97.50 square is 9,506.25, negative 73.50 squared is 5,402.25, negative 17.50 square is 306.25, 30.50 squared is 930.25, and 79.50 square is 6,320.25, and 97.50 square is 9,506.25, and 116.50 square is 13,572.25. So if we are going to sum it up, so the sum of squares is 63,904. By the way, the formula in finding the standard deviation for population is, if you have the data from the entire population, then we have to use the population standard deviation formula, which is, the population standard deviation is equals to the square root of the summation of x minus the population mean squared over n. So this is the standard deviation formula for population. For the standard deviation formula for samples, we have the sample standard deviation is equals to the square root of the summation of each data points minus the sample mean squared over the number of values in the sum, or n minus 1. So why we use n minus 1 for sample standard deviation? Because take note that samples are used to make statistical inferences about the population they came from. So when you have a population data, you can definitely get the exact value of the population standard deviation since you collect data from the entire population member. And definitely the standard deviation reflects the precise amount of variability in our distribution, which is the population. But when we use sample data, like what we have here, our sample standard deviation is always used as an estimate of the population standard deviation. So using n in this formula tends to give us a bias estimate that consistently underestimates variability. So reducing the sample n to n minus 1 makes the standard deviation artificially large, giving us a conservative estimate of variability. While this is not a unbiased estimate, it is a less biased estimate of standard deviation. It is better to overestimate rather than underestimate variability in samples. So the difference between biased and conservative estimates of standard deviation gets much smaller when you have a large sample size. So moving back in this particular sample, in this particular standard deviation sample. So again, we have a sum of squares of 63,904. So using this particular formula for standard deviation for sample data, we have S is equals to the square root of the summation of the data points minus the sample mean squared over n plus 1. So the sum of squares is 63,904. So we are going to substitute here. 63,904 over n. Our n is 8, so minus 1. Limitedly, this is 7. So computing the standard deviation for this sample is we have 63,904. So divided by 7, then square root, then therefore our standard deviation is, for this sample is 95.55. So S is equals to 95.5. So this is our standard deviation for this sample data samples. So moving on, to get the variance, what we are going to do is just to square the standard deviation. And that's the variance. But before that, let me give you an overview about variance first. The variance is the average of squared deviation from the mean. A deviation from the mean is how far a score lies from the mean. So variance is the square of our standard deviation. This means that the units of variance are much larger than those of a typical value of a dataset. While it is harder to interpret the variance number intuitively, it is important to calculate variance for comparing different datasets in statistical tests like the ANOVA or analysis of variance. Variance reflects the degree of spread in the dataset. The more spread the data, the larger the variance is in relation to the mean. So for example, so again, to get the variance from our previous sample, we just have to square the standard deviation. So we have a standard deviation from our same previous example, which is 95.5. And then to get the variance, we just have to square. No? That is actually S squared. That is 95.5 times 95.95. That will give us 9,129.14. So this is the variance of our data, sample data. So to find the variance by hand, we have to perform all the steps for standard deviation except for the final step. So same, if we are going to look for the variance formula for a samples, we have S squared is equals to the summation of data points minus the mean squared over n minus 1. So this is the variance formula for samples. In finding the variance for population, and finding the variance for the entire population, the formula is, so the population variance is equals to the summation of the difference between data points and the population mean squared over n. So just like the standard deviation, there is this biased versus unbiased estimates of variance. An unbiased estimate in statistics is one that does not consistently give you either high values or low values. That means it has no systematic bias. Just like for standard deviation, there are different formulas for population and sample variance. But while there is no unbiased estimate for standard deviation, there is one for sample variance. If the sample variance formula used the sample n, the sample variance would be biased towards the lower numbers than expected. So reducing the sample n to n plus 1 makes the variance artificially larger. So in this case, bias is not only lowered but totally removed. The sample variance formula gives completely unbiased estimates of variance. So why is not the sample standard deviation also an unbiased estimate? That is because sample standard deviation comes from finding the square root of the sample variance. Since a square root is not a linear operation like addition or subtraction, the unbiasedness of the sample variance formula is not carried over the sample standard deviation formula. So what is the best measure of variability? Well, the best measure of variability depends on our level of measurement and distribution. When we say level of measurement, for data measured at an ordinal level, the range and the interquartile range are the only appropriate measures of variability. For more complex interval and ratio levels, the standard deviation and variance are also applicable. In terms of distribution, for normal distributions, all measures can be used. The standard deviation and variance are preferred because they take your whole data set into account. But this also means that they are easily influenced by outliers. For skewed distribution or data sets with outliers, the interquartile range is the best measures. It is less affected by extreme values because it focuses on the spread in the middle of the data set. So we have more into this. That's all for now. If you have questions, do not hesitate to approach us. Thank you and good morning.